Hey everyone, welcome back from lunch. So we're going to talk about geolocation apps, the services side obviously, because it's a Python talk here, and specifically using Django. So we're going to go over a bunch of different things here, as you can see in my lovely agenda, starting off with just a bit of an intro and a bit about just cartography in general, how map calculations are done with or without code. Go into a lot of this presentation is going to be code heavy, which should be fun. So going to be showing a lot of snippets and whatnot, and then going through and kind of optimizing things and whatnot, and a few demos here and there. So to start off, obviously there's a lot of apps out there, and when I say apps, I don't necessarily mean like an iPhone app particularly, but apps that use geolocation as a service. Google Maps is a very obvious example. Everything from routing different directions to just showing places of interest. Big part of it. Foursquare, a check-in service that was very popular a long time ago, not as popular now. A new startup out of Toronto called Ritual, basically for ordering lunch, and uses geolocation to tell you what's nearby, but it also uses geolocation to remind you when you should leave based off of how long it should take for you to get there. Uber, obviously a lot of geolocation aspects, showing where cabs are on the map. It's also showing you, it deals with calculating the actual rate of your trip. So many different things in there. There's a cool app I've been playing or using a little bit called Periscope. It's basically kind of like a live streaming app, but it shows you on a map kind of where the live streams are happening. And the final example I have here, Find Friends, built into an optional app, I guess, in the iPhone. Basically, you can add friends and you can see, assuming they've agreed, you can kind of see where they are at any time. Just a little bit about me. I'm from Whitby originally, but I've been in Toronto now for about 10 years. I have a company called The Young Astronauts. We're an interactive media production company. We do web design and development, any kind of software, apps, games, whatever, and combine it with video production as well. And I also have another startup that's kind of being incubated by The Young Astronauts called B-Side, which I'm not going to get too much into, but these slides do have links that if you go to the address there, you'd be able to click on it and see a bit more. It may or may not have something to do with geolocation. Languages I work in, generally Python, JavaScript, and a bit of Objective-C. Definitely a noob at that, but I use Python and JavaScript pretty much any day, every day. And I also have a major passion for just workflow tools, building things, as most programmers do, you want to find a way to do the redundant and boring, repetitive things quick and automated. I have a website, tylersavery.com, which is pretty new, and I do live coding on livecoding.tv. I also have an Arduino and play with that, and I like playing musical instruments. Okay, enough about me. Let's talk about cartography, which is basically map stuff, been around for a long time. The very basics, obviously something called latitude and longitude, measuring your position in degrees. Latitude is basically your north and south parameter, and east and west is done by longitude. Pretty obvious stuff. Something called projections. So a projection is the way that you visualize a map. Probably the best projection ever made would be the globe, because it's actually three-dimensional. This is obviously a two-dimensional picture of a three-dimensional globe, but it's a lot easier to, if you hold it and you pull around, you can see how big a country is compared to another one. That's a lot different than, say, the Mercator projection, which I'm sure you've heard before, something, the further you go up on the map, the more stretched everything is. And this is just a way to make latitude and longitude lines basically all line up. A problem with this is when you look on a map, if you'll see up here, we'll open this again, but you kind of see Greenland looks huge, but, and Australia looks really small, but when they're actually, if they were, positioned over top of each other, you actually see Greenland is considerably smaller than Australia. So there's different other projections that kind of help with this. One of the ones I like is the Dymaxion, and hopefully you can kind of see it on the screen. Basically, it folds out as like a bunch of triangles and actually is a lot more relative to how things are. There's a few other ones you can click on here. I'll load this one, Galpeters. This actually kind of shows a lot closer to, it looks really stretched and funny, but the comparison is a lot closer, at least in the north and south, from what I know. And then I have this thing here, I'm not going to go through it all because it's going to take too much time, but it's the obligatory XKCD, which just kind of goes through all the different ones and makes fun of them. But I'll let you guys look at that on your own. And there's many more. I just named a few. Here's a huge list of many different projections. Again, you can click on it yourself. Oh, no. Sorry. There we go, a little more preview. Another important thing to sort of bring up before we get into the code side is what's called an SRID. It's a spatial reference system identifier. A very common one is the WGS84. A lot of geolocation services rely on this one. And it's just essentially a way that the data is stored and compared with each other. I'm not going to get too much into the heavy technical on that right now. It's also sometimes known as an EPSG code. And if you're using a PostGIS database, which is Geography Information Systems, you'll have a spatial ref system table, which kind of takes this data and makes it make sense for your code. Okay, that's enough theory for now. We may do some more. Let's talk about the code side of it. So a few tools in our tool belt would be something called GeoDjango, which is now actually a built-in module in Django. You still have to include it as an installed app, but it's pretty much good to go, and you run a migration, and you'll have all the tables you need. PostGIS, it's an extension for Postgres, specifically for geospatial information. PyProj4 is a really nice piece of software, obviously Python-based due to the name. And it's meant for like cartographic transformation. So things like measuring distance, seeing what overlays with things and whatnot. And another thing that's going to come up later in this is what it's called k-means, and it's actually a Postgres extension meant for clustering data. So I won't get into that too much now because we'll see a demo of it and it'll make more sense. Okay, code stuff. So I kind of put together a very lightweight project, mainly for the purpose of this presentation, pulling from some different things I've built in the past. And I'm kind of calling it, I guess, GeoDude. Here's the website for it. Or maybe GeoDude with like a DJ, I don't know. It's just a project, it's a private repo right now, but I may add on to it a bit more and collaborate with people, and maybe we go open source, who knows. The stack of it is, it runs on Ubuntu 14.04, because I trust that one a lot. We got Vagrant running. If you were at the Docker presentation in this room earlier before, you'll know a bit about that, but it's basically a virtual machine development workflow library so that you can, on your Mac, on Linux, on Windows, run Ubuntu really easily just by configuring a file. And then you SSH into it and everything. We're using Python, pip, Django, obviously, Django REST framework, and Postgres with PostGIS, which I brought up. And there'll be a little bit of Redis that we'll get into as well. Those are the main pieces. And the project structure, I mean, it's a Django app, so it's pretty straightforward. Basically, the main core things are in the API folder. How readable? It's a little small, right? I wonder if it's better to look at it in code land. Is this more readable? A little bit. But basically, it breaks down into a few different apps. The main app is the API app, which has all the location, like the location models. You'd put any other model you'd need in there. And there's another app that's just what I call front end, anything that is public facing that's not going to be like an API response. It's going to come back as HTML, goes into there. It doesn't necessarily do public facing things. And then I just have my root app, which is where the main settings file is and tests and whatnot. Pretty straightforward sort of thing. So there's a few important settings that you would have to have set up. Obviously, one of them is including the REST framework, because we're going to be using that. Also including the API app that we made, and a few more. There's a few settings that we're going to get into, such as when we're doing the clustering, it needs to know a few different things. What model to use, what the column's called. For the front end, there's a Google Maps token that we'd be putting in here. Database, just like any other Django project, the main thing is that you need to use the gis.db.backends.postgis instead of the standard Postgres database, because we are dealing with geography here. And then there's just some basic Redis set options there too. Sweet. We have a model here, and the model is called location. You can call it map pin, you could call it whatever you want. We're calling it location. Has some basic stuff, a title, a description, whatever. The key things are, though, the key piece of the model is this thing called point, which is actually a point field built into the GeoDjango. And it basically stores a latitude and a longitude. And rather than storing the latitude and longitude directly in the database as other columns, we actually just have properties of it. So these are just methods where if you use the property decorator, you can get to it without calling it as a function. And we actually just return point either the first instance of it, the x, or the y. 0 and 1, either or works. Obviously the admin, just showing a few things, what we'd want to show in the list view and what we'd want to be searchable. Okay, we'll go through that. Now, we're using Django REST framework. And how that really works is, this is kind of like, I mean, Django in general is an MVT framework, model view template. The view is kind of like the controller in most frameworks. And in an API application, I like to think of it as a model view serializer. Serializer kind of being the template of what actually comes back in JSON generally. So this is just kind of listing all the different things we'd want to return back in the API. And this application right now is just a read-only application, aside from the admin and everything. The actual, through the API, you're only ever reading, so we're just making everything a read-only field, so someone can't just post to it or do a put request or whatever. Then just the URLs, we just have to hook in two different ones, locations and locations with a primary key after it, and that way we can get the list of all the locations, or we can get a list, or just a single instance of a location based off of its ID. And you'll see that reflected in the views here. We have location list, location detail. There's actually some extra lines of code here because technically this isn't needed. It would do this by default, but I like to kind of put them in because sometimes you'd want to override something when a list happens or when a retrieve happens. But this is all just basic open source Django REST framework things. So let's see that in action. So if I was to do, first of all, we'll look at the admin. And see the locations here. So I'm just using the Bootstrap theme in the admin. It's just a very one pip install and one line of code, and you get this nice looking Bootstrap theme. So these are all the locations that I have. Now what I did for this was I went on, and I'll show you the site, but basically the Toronto, one of the Toronto data websites, and I pulled all the drinking fountain locations down from Toronto so that if I was thirsty, which I am, we can find the closest one. So that's the admin, and it's obviously very basic. The main difference here, because we are using the PostGIS, is one of the, instead of just a text field here with like the latitude and longitude, we're actually seeing a map. It's a little hard to see, but there's this little circle here, and technically through the admin I could move this somewhere else if I wanted to and break everything. Oh, someone would be upset because they'd think a water fountain was there. So I'm not going to save it for their own likeness. Okay, so that's the admin, and if we do an API request, what you'll see is a list of a bunch of water fountains coming back. You notice there's only, I think, 10 here. That's because we're using Pagination, which is something built into the REST framework as of version 3 or something. And so what I can actually do is, paginate through this stuff. Yeah, cool, I get all these locations. Or I can, look at this one, okay, ID 23, and we could just see, one of that. It's not an array now, it's actually just one object. So basic Django REST framework stuff. Now, I mentioned where did that data come from. So Toronto Data Catalog is a really cool source of tons of different geolocation information, ambulance locations, let's see, bicycle counts and locations, bicycle shops. You could go through this all day and come up with cool app ideas based off of this data. And the problem that I had with it, which isn't a problem, but what they end up giving you if you download it is a .shapefile and a couple other little files, meta files that go with it. And it's kind of like a already compiled like binary sort of file, basically a database, like what you'd see if you looked at like an actual, what a database data looks like. And it's not very user-friendly. So what I like to do is convert it to what's called Geo JSON. It's basically a JSON, it's just JSON, but it has kind of like a conventions with it. And what you can do is you can install something called GDAL right on your Mac. This is just the command for Mac. You can obviously look up commands for other operating systems. And all you have to run is this OGR to OGR and basically pass in a few different parameters, telling it to use Geo JSON and the output and the input shapefile, and it will come up with the Geo JSON version of it. So GIS stands for Geographic Information Systems. GDAL stands for Geospatial Data Abstraction Library. And then OGR used to stand for OpenGIS Simple Feature Reference Implementation. And then they made a bunch of changes that didn't make it following the exact standards or something like that. And now it just stands for like it literally stands for like OpenGIS something something something. So it's kind of like I don't know. It's weird, but that's what it used to stand for, and that's just coming from this command here, OGR to OGR. And this is what basically a Geo JSON file looks like. The main things, this is kind of just metadata about the whole file itself. The main things are in features, you generally have an array of different features, and they can have types, they can have different properties associated with it. There's conventions on kind of like the primary root pieces, but once you're in properties, you can kind of do whatever you want. I'm sure there's certain conventions that people follow, but when I look at the difference between this one and another file, sometimes it's not like you always have just address and type. It can be a mix of different things. And that's obviously important properties, but geometry is very important. This is just a point object, so it all has its coordinates, but the geometry could be a whole polygon. It could be a sphere, or something like a radius, a circle. It could be a bunch of different things. So that's just the most simplest one, point data, and it's one of the most common. Now, what I basically did was wrote, this is a fairly simple script, which I won't go super into detail with. You can look at the slides and copy and paste as you want. But all it does is it's basically a page you go to, upload a Geo JSON file, and it will go through and create basically the location objects, which is the model that we showed earlier. And it will import them all in, and there's no crazy sanitation happening right now. If I ran it a bunch of times, there'd be duplicate records, but it was just enough to kind of get a simple demo together. Again, look through it, play with it on your own time if you wish. So we have all this location info, we have a whole bunch of data, and there's some problems with it. First of all, there's this pagination happening, which pagination's good in certain things. When you're looking at things in like a list view and you want to have like infinite scroll, that's great. But if we're trying to query everything and put things on a map, we're going to have to make a lot of calls to the server or turn off the pagination or whatever other option, and that's not really going to work for us. It's also, if we were to send everything back, all however many thousand drinking fountains are in Toronto, it's a lot of information. It's going to be a big response. So slow and bad for bandwidth and costs and everything. There's also a lot of data in there. In the current, which I think I still have open here, we're getting all this address, this title. In theory, we could have pictures. We could have, the person that owns that water fountain. I don't know. There's a ton of different things we could have. So it becomes, a lot of data coming down. Right now, there's no caching happening, so it's, querying the database every single call. And like I said, it's hard to make a map with this. So how do we fix that? One thing right off the bat is if we are building a map-based thing, we don't have to show them the whole world. We don't have to show them data for the whole world. Let's just show them what's nearby. So what we can do is in the request, expect a location and even a zoom level of that map. And then we only send back things that are within bounds of that. Ones they could see, and maybe a little bit off to the left, a little bit off to the right, up and down, just so that people can move around the map without having to make another call. We can also streamline the response a bit. Instead of sending all the info, like the title, like we have here, maybe we just send back the latitude and longitude. Maybe we call latitude just LAT, a little bit smaller, although if you're using gzip, it's going to pretty much be the same thing. But we could just send back the basic stuff, and then when someone clicks on it, maybe we make another call just about that one thing and get everything back that we would need. We could also cluster. And I'll show you what that's like in a minute. So to get a better understanding of this, we have to go back to a little bit more theory here. I know I said the theory was over, but I lied. So there's this awesome function here written out mathematically of map tiles. Now, these map tiles, the way it works is based off of what zoom level you're at, the world is broken up into these tiles. When you're zoomed out really far, like you'll see in almost this one right here, there's only a few tiles, because you're really zoomed out, the world's not that big. But when you zoom more and more in, it's exponentially more and more tiles left and right, north and south, east and west, however you want to look at it. So this is basically a function that, based off of a certain zoom level, and a certain latitude and a certain longitude, we can return back an x and a y of what tile that would be. Google Maps uses every map service basically uses this. In fact, if you were to open up Google Maps or anything, I'll open up OpenStreetMap just because it's a little bit easier. You can actually see these tiles very easily. So you can kind of see here, and here, and here, there's tiles. And you can actually even see the name of it. They have the URL right here. It might be a little small. Let me zoom here. I probably close it. It's a little small, but you can see that it's 11/572/747. What that means is show me the tile at zoom level 11, x of 572, y of 747. And basically, you rely on the client, in this case, a little bit of JavaScript, to determine based off of where you are on Google Maps, what tile do I want to, what do I want to basically query? And we send that up to the server. This concept is known as Slippy tiles, and you can see a lot more info about it here. And this is where I think I pulled that function from. A lot of math. There's some pseudocode. There's that function, and here's the Python version of it, which I've pasted into the slide here. So it's a snippet. You don't have to necessarily. It's a lot of basically, I don't know, trigonometry sort of stuff. But you don't necessarily have to fully understand. You just have to know, if I pass in a lat, a long, and a zoom, I'm going to get back a tuple of an x tile and a y tile. Now, to basically make this work, we go back to our view that I showed you before, and we're adding one more thing here called location map. And it's still a list-based request, get request, and it's going to send back multiple things. And essentially what we do is we pass in that zoom x and y to this cool function called map clusterer, which I'll get into. It's obviously not just a one-line thing. It's a whole huge file. And then we get those markers and we send those back. And we have to add a URL to support that. And you'll basically see now it's map / the actual zoom level / the x / the y, similar to how we saw in OpenStreetMaps. Now, in any cluster, which you can look up on your own, it's this project that I found that seems to suit the needs of this. And it's Python and PostGIS based, so it works really well with our stack. The one thing, it has a lot of functionality, a lot of different things, but this is kind of like the key part right here. And it's an SQL statement. This is the SQL when it is expecting a bunch of Python variables. They're just being place held right here, et cetera, et cetera. It's hard to read that. And even this isn't the easiest thing in the world to read, but it makes a little more sense. Basically, what it's doing is it's kind of like a query inside a query. In the deepest query, it's looking for geometry that's within a certain bounds. This is basically the lat and longs that get calculated. And then from there, it's finding out, it's running this thing called k-means, which I will mention in a minute, and which basically returns all the clustering information. So, and then we actually execute the SQL. This is just building the SQL, and then you actually execute it and return it back to that function that we saw. So k-means, I mentioned earlier, it's a PostGIS or Postgres extension, and you can install it on your Mac or a bunch of other, I think any operating system probably. And what it does is, and I don't know all this crazy science behind it, but it's basically like a scientific library for looking for patterns at certain things and essentially clustering. You've seen on Google Maps, maybe not Google Maps, but I'm sure you've seen on certain map sites, when you're zoomed out, maybe there's 1,000 things in this one little spot, and rather than showing 1,000 pins, it's showing you just condensed, hey, there's 1,000 things here, zoom in to see more. That's basically what I'm getting at here. And it's better, if we're calculating it server side, because then we're not sending back all this annoying data. What we're sending back is either a pin or a cluster with, a number associated with it. And this is what it would look like. This is just a bit of the response, but if I was essentially at apparently zoom level 13, this tile and this tile, I would get back a few different things. One of them is showing me, okay, there's a count of 8 at this latitude and longitude, count of 2 here. Here's one with a count of 1 though. And the difference here, because it only has 1, is it is going to turn out to be a map pin, and we associate the ID of that location. That way we can, when someone taps on it, clicks on it, whatever it may be, we can go and pull out more information about it, call the API again. So this is a lot more, this represents right now 15, 16, 18 location pieces, but it's only sending me back 4 things because we don't, at that zoom level, there's not enough, you don't need that much information. And in order to make this work, there's obviously a bit of client side. I streamlined it to just the most important parts of the JavaScript here, because this is obviously a Python conference. But basically, when the update map happens, which is, there's an event listener for when you move around, when you change your zoom level, Basically, we calculate what the zoom, lat, and long currently are. There's a utility function, which isn't included here, but it's basically the same as that Python function I showed you, long to tile and then lat to tile. And so that's going to return me back. I already know the zoom, that's really easy, but this will return me an X and a Y of what tile I'm on. And then we query the API, and this is basically the query API function, which just checks to make sure you have those 3 things set, and then calls that URL, and it's going to return back this right here, or something like that. And let's see that in action. So this is me looking at Toronto. Here's all the drinking fountains in Toronto. So at this zoom level, a lot of things are obviously clustering because they're pretty close together, but we can see a few random outliers here. So this one right here basically tells me a little bit of info about it. Again, we could make it more exciting and have pictures and user comments and whatever else we wanted. The point is we're not sending all that data back until we do the one, the request on that exact one. And if I was to zoom, which seems to work, you'll see that the server is going to recalculate things for me based off of that zoom level and change as needed. And if I zoom out really far, instead of seeing 1,000,000 pins or 629 pins, you're just kind of seeing one cluster. OK, so very quickly, because I know my time is almost up and I want to have a bit of time for questions. Something that you might want to do also on top of this would be just optimizing with Redis so that if someone, say you have 10 people using the app in Toronto, you don't want to have to keep calculating the same thing when the data hasn't changed from the same point of view. So pretty easy to implement. You basically would install Redis. You make the key kind of like the map _zoom_x_y. And if that cache already exists, it basically just sends it back right from Redis without having to hit the database. If not, it does the normal process and then saves that to cache for 5 minutes or whatever time you kind of would want. Yeah, and then I'll just leave these in the slides, but basically I wanted to also mention just other cool things you can do with GeoDjango. Basically, calculating distance between points is obviously a pretty important thing for a lot of different apps. And this is just showing the difference between if you were to just do it with raw trigonometry, math, basically, it's quite a few lines, whereas the same sort of exact same thing here, same function, we are just basically creating those 2 points as geometry objects, and then we're going point 1 dot distance to point 2, and then multiplying by 100 for some reason I forget at this moment. Okay. And then there's also queries you can do to like check on, if something overlays, maybe you have a polygon of a park, and you're like, I want to see if a drinking fountain is in that park. You can kind of call queries like this. You can see if it's within a certain distance. You can see if it's within a certain polygon. Okay. So I want to wrap it up because I want to take at least a question or two if possible. Thank you.
Thank you, Tyler. So yeah, we have about time for maybe 1 question, maybe 2 if it's fast. If anyone wants to come up to the mic and if you have a question. If someone else has a question, just like come up now and then.
Use all the time on my questions for traveling. Yeah. Cool.
Hi, I'm trying to solve a problem where I'm trying to calculate all the boundaries. Say, for example, you're calculating the boundaries of all the cities in Canada, or even more granular boundaries of postal codes. So as you can see, it's a lot of data that's coming back.
Yes.
Have you solved the problem of displaying that in a front end somehow?
Definitely. I've worked on quite a few projects that have, when you're in development, you just have seed data of 100 locations or something, and then when you get closer to production, you're like, oh, we should import the real data, and then you realize you have 1,000,000 records. Things like, the clustering is obviously a very good way to do that. It can be accomplished with the way I showed you in terms of tech. In terms of presentation, there's other ways, like it doesn't have to be those circular sort of things. It can be heat mapping, which is pretty easy to do as well. It relies similarly as clustering is built. You just display it in like sort of a different way. So yeah, to me, like the best way is you never want to send to the client. You don't want the client to process all the information because it's a huge request, right? And it's a huge amount of data for it to do. You kind of want to know something about the client. Where's it looking right now? And what zoom is it looking at? And then server side basically calculating this, which is essentially what we went through during the talk.
Sorry, a quick follow-up.
Yes.
Do you have any apps that you use to slice and dice large data? Like I've used QIS, I think, to slice
Yeah.
portion of the map. Is there is the command line tool that you've put out
Are you
there?
talking about if you had like a bunch of info for all of Canada and you only wanted to look at it like
Say
just Ontario or something?
Yeah, just Ontario's, yeah. Or even
I mean,
city.
you could write a pretty simple script with Django, GeoDjango. Basically, you'd create a polygon shape of the area you want to look at, and you'd essentially run a comparison. Return me all the things that fall within these bounds, and then you could export that to a Geo JSON file or SQL, or just put it in, delete all the other ones from your database or something. Like, definitely possible. Yeah. Cool. Thank you.
All right.
All right, that's it for
thanks.
me.
Yeah.